I'm going to show you a couple different methods for finding all the real zeros of a polynomial, the real and the imaginary zeros, and this time I'm going to show you a method using grouping, factoring by grouping. The next video we'll take a look at how to solve this using a table or using a graph. So the grouping method works like this. I want to start with factoring my polynomial using grouping. So the way I like to do it, if you remember from the video or from class, I like to factor using the box. If you know another way to factor using the grouping method, go for it. So my method works like this. Put all 4 of your terms in the box, just in order like so. And then what I'm going to do is look across the rows and up and down the columns for greatest common factors. So for example, looking across that row, or that row right there, I can see that both of those are divisible by 121. Along the top, I can see I can get an x squared out of each of those. Then looking up and down the columns, each of these are divisible by x. I'm just looking for greatest common factors. And then finally, these have nothing in common, but I could always take out a 1. And since I want to match signs, I'm going to match that up to a -1. So the way this factors then, it factors down into x minus 1 times x squared plus 121. I would try to factor again if I could, and some of you may be tempted to try the difference of 2 squares on this binomial, since you know that the square root of 121 is 11. However, since there's a plus sign there, I cannot do the difference of 2 squares. It's not a difference, it's a sum. So I factored as much as I can, but I've done enough to get my zeros. So what I'll do is I'll put each parentheses equal to 0 and then find my 2 zeros, my 3 answers. Sorry, this time. I have 3. So I will set that equal to 0 and add 1 to both sides. So x equals 1 is going to be one of my solutions, one of my zeros. The other side, I cannot factor that, but I can solve this. So x squared plus 121 needs to equal 0. I can solve this using the quadratic formula, or what I'm going to prefer to do this time is just solve it by taking square roots. So I'll subtract 121 from both sides, and then go ahead and take a square root. And I remember that when I take a square root when I'm solving, I get 2 answers. There's the positive and negative version. So plus or minus, and I'm taking the square root of something negative, so there must be an I in the answer. And then the square root of 121, since that happens to be a perfect square, there's no more square root left over. It's just plus or minus 11i. So there are my 3 answers. The real answer is positive 1. The 2 imaginary answers are plus or minus, the positive or negative, 11i.